All right, so last lesson we were talking about recognizing proportional relationships from tables and from graphs. And now this time we're going to talk about what those would look like if they're written with an equation. So the important thing to remember is if you want to take a proportional relationship and you're going to write it in an equation, just like the graph had a specific form, it had to go through the origin and be a line. Same thing with the equation. The equation has to look a specific way if it's a proportional relationship. And so this right here tells us what that is. It says any proportional relationship can be represented with an equation of the form y equals that constant of proportionality times x. And that's it. So if you have an equation that looks like y equals any number times x, then it will be a proportional relationship. And this number is your constant of proportionality. So y equals 5x. That's proportional. The constant of proportionality is 5. Y equals negative 3x. That is a proportional relationship. Constant proportionality is negative 3. But if I have anything else, if the equation looks any different than that, okay, if it's y equals 2x plus 7, then it is not because it has this extra stuff at the end. It can only have just a number times x, and that's it. All right. We can also get these equations from the tables and from a graph. So, and the way you do that is figure out what the constant of proportionality is. Once you figure out that constant proportionality, you know what the equation will be. So if we look at this one, we have tickets sold and the cost for those tickets. First thing we need to figure out is this a proportional relationship? So from the last lesson, we know we could take these, you take each pair, the 16 and 4, the 20 and 5, 24 and 6, 28 and 7, and see, well, do they have the same, do they reduce to the same thing? So 16 divided by 4 is 4. 20 divided by 5 is 4. 24 divided by 6 is 4. 28 divided by 7, 4. So yeah, they do all reduce to the same thing. They all reduce to 4. And so that is your constant of proportionality. So that means if I wanted to write this as an equation, I know it has to be y equals the constant of proportionality times x. That's it. That's the equation for this table of values. The same idea with a graph. All right, first thing I have to check is this graph, and this is the same, this is the data from this table. So we know it should be a proportional relationship, but the way we checked from a graph was, is it a straight line? Yes. Does it go through the origin? Yes, it does. It goes through 0, 0. Then that means it is a proportional relationship. Now, once we know that, how do we figure out what the constant of proportionality is in a graph? Well, if you remember from the last lesson, all you do is you look at 1, okay? When your x is 1, what's the y value? That's your constant of proportionality. So in this case, when x is 1, y is 4. So we know 4 is going to be the constant of proportionality. And so again, if I want the equation, I know it's got to be y equals that constant of proportionality, so 4 times x. That's it. So it gives us the same equation as the last one, which it should because it's the same information. This one, it was the information was in the graph or in the table of values, and on this sheet, it was in the graph. But it was the same information, so it should have given us the same equation. But that's it. You can always check, use, does it go through the origin in a straight line? Then it is a proportional relationship. Find the value when x is 1. That's your constant proportionality. You get your equation. If you have a table of values, reduce all of them to make sure they are the same. Once they are the same, remember what it is when the denominator is 1, that unit rate. That's your constant proportionality. Plug that in for your equation. And that's it.